a synthesis. So an example of a synthesis reaction, just to have one to look at, would be something like this. Mg plus O2 goes to MgO. Synthesis. Is this balanced? How would we balance it from last class?
By adding the 2 in the front.
2 in front of here.
And 2 in front of
and 2 in front of here. All right, so this is a standard synthesis. This falls into the synthesis category. There are other synthesis reactions in organic, but they're always combining 2 things together to become something larger. Decomposition. You start with one compound and you end up with multiple elements. So you start with one compound, breaking up into multiple products. That's decomposition. It is literally, most of the time, the exact opposite of a synthesis reaction, but we'll be looking at a very specific decomposition later today. Combustion. You may have memorized this CHO, CHO. If you have some kind of hydrocarbon, so it's either a hydrocarbon or organic, if you have something that's a hydrocarbon or some kind of organic compound with oxygen, and you apply oxygen to it and some energy, you burn it, you'll get carbon dioxide and water as products. And remember, these are specific. These are, you gotta memorize that carbon dioxide and water are the products of the combustion reaction. As long as it's complete. We'll talk about incomplete combustions when we get to organic chemistry. We're only looking at the classics right now. The ones that you should have already learned at some point. Single replacements. You may or may not remember. This is when one element kicks another out of a compound. So you've got an element that's alone and by itself. And if it is powerful enough, it will kick out one of the elements from the compound and assume its position. And then the other element will now be kicked out by itself, whichever one's weaker. You may recall we had something called an activity series for that. You do not need to memorize the activity series in this class. Right now, just assume if you see a single replacement reaction, it's happening. We'll talk about what you do need to know later on in the year. Double replacement. You may or may not remember this one. This is where you take the inner 2 parts of 2 ionic compounds and the outer 2 parts and you swap partners. And so you're basically doing an ion swap. I'm going to show you a couple of examples just so you have them for each one. Decomp could be something like NaCl goes to NaS plus Cl2 gas. Combustion could be C2H6 plus O2 goes to CO2 and H2O. C2H6 is ethane. I'm sorry, ethane. It's a gas. 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 And the standard state for water is actually liquid. Gas, 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 liquid. Now, go ahead and balance this. What would we do first from last class? What should we balance first? Carbon. Hydrogen would be 3. How many oxygens do I have now? 2 times 2 is 4. 4 plus 3 is 7. So this is 3.5. You can use decimals, and actually you should. For Cambridge, you should. Later in this class, we'll be looking at combustions, and we'll be using decimals. Because one of the things you're going to need to know is when you combust 1 mole of whatever that compound is. And so, yeah, decimals are encouraged. Single replacement. Let's take a look at one. Mg plus HCl. This is one that I've shown in the first year chemistry curriculum. You've got magnesium, it's a wire, you throw it in acid, we know that it will corrode. What is that reaction actually? What happens? What will magnesium swap with?
Hydrogen.
So magnesium kicks hydrogen out. Hydrogen becomes what? H2. So when elements get kicked out, they kick out in their standard state. Plus MgCl. 2. Balance it? How do we balance it?
Add 2 to both.
This will be 2. And
Oh,
that's
no,
it,
don't add it.
right? That's it. Double replacement. Classic double replacement is this one. Some sodium hydroxide and hydrochloric acid, also an acid-base reaction. Most likely the lab will be doing or something similar on Friday. When we do the titration, we usually just mix an acid with a base to check the pH change. What are our products here?
Sodium chloride and water.
Right. NaCl. What's the state of matter? If salt's in water, what is it? Aqueous. And then you get water, which is liquid. So far, so good? All right, these are the reactions that we call the classics, the ones that we spend in pre-ACE going over for like a month. We go over these reactions, you have to complete and balance each of them. In this class, it's assumed that you know how to complete and balance each of them, but today's the day we're gonna look at some examples together, and you will get practice homework questions too. I'm pausing to give anybody time they still needed to write down any of the examples, and then we're going to continue. Is this enough information to write the products? For the first reaction, it says it might be useful to identify the type of reaction before writing the products. Notice I did leave out the states here, so you don't have to write in the states unless asked. What about this first one, Al plus O2? What type of reaction do you think we got going on here? So you should write that underneath. Synthesis. Synthesis means we need to smush these elements together to form a compound. But to form this compound, it doesn't just form in any way. You have got to make the correct compound. How do we do that? Right. You have to make the correct compound before you balance it. This is where, for those who didn't get it in freeze, this is where they went wrong. They just went AlO2, and they were like, smush, that's it. It's not it. That's not how aluminum and oxygen combine. How do they combine? Aluminum has what charge? +3, because we memorized that, right? It's in group 13. And oxygen has -2. To make the correct compound, what must we do now? Crisscross, right? We make sure that the charge of each element balances so that the whole entire compound has an overall charge of 0. And in order to do that, the easiest way is just to cross the charges to become the amounts of the opposite element. And so this becomes Al2O3. Are we good with that? So that's the first step. The first step, you got to make the correct compound. After you make the correct compound, now you must balance the equation. So how do we balance this one? Yeah, I'm going to start with oxygen. 2 and 3. First number, they both go into a 6. Now aluminium has how many on the product side?
1.
4, right? Step 2.
4.
So I need to put 4 on the reaction side. And that'll be my answer to the first one. 4Al plus 3O2 goes to 2Al2O3. If I had asked for the state of matter, what would you suppose it would be for the reaction to the product? What's the state of matter for aluminum? Aluminium.
Solid.
Oxygen. And aluminum oxide is an ionic compound. What would that state be? There's no water present though, right? If there's no water, then it's gotta be
Solid.
solid. Ionic compounds are solid unless there's water involved, then they're aqueous. Unless there's a precipitate, which we have not gone through yet. Next one, Fe plus CuSO4. Technically, to solve this, I need to give you some extra information. I was very careful in the homework. I read it through to make sure I didn't give you any questions like this. I'm going to tell you that iron makes a +2 charge in this case. Because it's a transition metal, you have to be told what its charge is going to be, or else you're not going to figure it out. Because remember, transition metals can have multiple charges. Iron has multiple options it could be. So I'm telling you, just in order to solve this, iron makes a +2 charge. If you want to know why I came up with this assumption, it's because if we don't tell you which compound's made, generally speaking, the lowest oxidation number possible for that element will be the one that's made. And for iron, that is actually +2. Do you have to memorize that information? Absolutely not. I'm just telling you how I came up with that. All right. So what type of reaction is this next one? Fe plus CuSO4. Single replacement. If I were to throw the states in, single and double replacement reactions both happen in water. So iron is a solid, and copper sulfate would be here in the aqueous form. What happens now? What's actually going to happen in a single replacement? What do you got to do? What's the template?
Fe is gonna replace one of them.
Right. Which one? How do we know?
Whichever.
How do we know if Fe is going to replace copper or if Fe is going to replace sulfate? This is an important question.
Whichever one has a larger charge.
Does anybody remember? How do we make the decision? Go ahead, Diane. Yeah. Your compound has to be made out of a positive part and a negative part, right? So if you put iron with copper, you're going to have two positives, and that's not a thing. That's not a thing ever. It's never going to be a thing. If you do that, I'm just going to probably write on your exam, not a thing. Doesn't exist. Sad face. Okay. Do we understand that though? So the idea is that metals replace metals, non-metals replace non-metals. And that's what I would have said before. Metals replace metals. And hydrogen, because remember hydrogen does its own thing. It has a positive charge like a metal. And non-metals replace other non-metals. So at this point, that's what you gotta know. So what do we do? Iron's gonna kick out copper. So copper is now by itself. And iron's gonna get together with sulfate. Because it's in water, the ionic compound would be aqueous. That's why I'm writing it that way. How do I know that it's FeSO4? How did I just know that?
Because sulfate is always SO4.
Sulfate is actually a -2 charge, and iron is a +2, so it's a 1-to-1 ratio. That's how we know it completes to become FeSO4. Do I need to balance this?
No.
No, it's already balanced. All right, third one, what type of reaction? Combustion. So the products you've just got to memorize are
Carbon dioxide and
carbon
water.
dioxide and water. Balancing is always the part here that's like you. So I need 6 carbons. I need 6 hydrogens. How many oxygens? 6 times 2 is 12 here. 6 times 1 is 6 here. I've got 18. What number do I put in front of here? 9. Because 9 times 2 is 18. So 1966 are the numbers to complete that balance equation. One at the bottom, what's that? Single replacement, right? So this is Zn SO4. SO4. I'm not going to write the state in because I wasn't asked. I was just writing just to show you what they would be. And then what's the other thing that's kicked out here? It would be kicked out as H2. Not because that's an H2, but because that's how hydrogen exists. This is actually already balanced as well, so life is good. Life is good if it's already balanced. We've got more. And actually, I wanted to bring something up before going forward. I had something, it should be printed on yours, yeah. I think I added it after I already sent this to myself by email. There are some acids you need to memorize. You may want to highlight that on the first page where the objectives are. Cambridge assumes you know this. I said you had to memorize these in pre-A, so I'm telling you now, go ahead and memorize these 3 acids. It's not a lot, but it means a lot when you add everything together. you should know that HCl is hydrochloric acid by name, back and forth. You see HCl, hydrochloric acid. You see hydrochloric acid, HCl. That should be something that's just like memorized, straight up known to you. Because if I write HCl on a label, I don't want to write hydrochloric acid. I might just write HCl on the label, and you need to know you're working with acid. H2SO4, you know what that is?
Nitric.
I think I must have read it in a different order. H2SO4 is sulfuric, and you just need to memorize that. And then HNO3 is nitrate. These three specific formulas for these acids do need to go ahead and just add them to things you need to memorize. You'll see in the homework why, the way the questions are worded, they're going to list them by name, and you need to know their formulas. So make sure you have them on your, these are the things I need to know list. So that's iron and HCl, hydrochloric acid. What now are my products going to be? Remember, iron is going to be Fe+2 in compound. Just because I'm telling you this, I gave you transition metal, so I have to give you this information. So what do? What type of reaction is it? So iron is kicking out hydrogen. You get FeCl what? 2. And H2. What else do I got to do?
Balance it.
So put a
2 in front of
right
it.
there. Next one, NaOH and H3PO4. Uh-oh. Uh-oh. What are the products this time? Is it NaPO4? You may remember that I listed them out like this in the past, where I would identify each ion so that you can make the compounds correctly. What's the ion for sodium? Na is a +1 charge. What's the ion for hydroxide?
B-.
Is OH -1, right? What's the ion for H? For H? +1, right?
Yeah.
And what's the ion for PO4? Negative what?
2.
No. Negative 3. It's one of the ones you gotta memorize, right? But you can get it from the formula. You can crisscross reverse to figure out what it is. Why is it essential that I'm doing this? Because when you come up with your formulas, when you put these two ions together to swap, it's not NaPO4, it is Na3PO4. And you have to understand that. This is Na3PO4. It's because when I put together Na+1 and PO4 -3, this is how it crosses down. And then what does that mean water is? H+1 and OH -1 is just regular water, right?
Yeah.
So you don't get tripped up with that 3 there. Plus H2O or HOH. So how do I balance this then? Remember, step 1, make the correct formulas. Step 2 is to balance the equation. How do I balance this? I would start with the 3 sodiums. Put a 3 in front of NaOH. 3 sodiums done. Now I got 3 OHs and 3 H's, which means I actually have 3 waters. Because remember, water is the same thing as HOH. I can help you remember that. So double replacement reactions can be nasty if you have to figure out the charges. If they don't automatically balance, you should do what I did here. Or something like it, even if you do it mentally. What about this one? The next one. What is the ion for NH4? NH4 what? +1. What is the ion for sulfate?
SO4 -2.
SO4 -2. What is the ion for calcium?
Calcium +1.
+2. And these are the little things that are going to mess us up. And OH?
-1.
-1. Now this time I'm writing it out a little bit easier for room. This is A, this is B, this is C, and this is D. So remember your outer 2 parts go together and your inner two parts go together. Maybe this will be a little bit clearer. So what is my first product?
NH4OH.
NH4OH. And my second product? Ba.
EASO4.
SO4. And balancing, what do I gotta do? I got two OHs here and two NH4s, so just put a
2
in front there. That's it, that's all you gotta do. I mentioned it last class period, the balancing in this class tends to be pretty easy even compared to what we did in pre. The balancing itself is not gonna look wild. It's usually gonna be pretty simple numbers until we get to redox. I'm sorry in advance for that. Redox is, it is what it is. All right, we did this last class. I just left it in. If you'll recall, we did this as one of the questions. I took some of the others out, but in sake of time, I want to make sure we get to what we got to. Let's go over this one, though. I do want to look over how could this look on a paper, too? How could this look on a paper, too? How could our classic pre-chem level reactions look? This is a diagram, right? What is this telling us about barium? Barium reaction to this, barium reaction to that, barium heat in there, that. What is barium in every single one of these instances? It's a reactant. They're just writing the arrows to your products in different directions. So you have three different reactions going on here. Can you figure out, for reaction 1, what's the missing other reactant? By the way, reactant and reagent are the same thing. So you may want to write that out for yourself. It's another Cambridge terminology switch. Reagent, some people, it's an older term for reactant. A lot of doctors and nurses still use it. So reactant and reagent are the same thing. What is the reagent needed for reaction 1? So read this as barium plus something makes BaNO3 plus H2. Can you figure out what the missing piece is?
OH2.
What's the missing piece? They're asking for you to figure out what's this? What did I have to put with barium to get those products? It has to be something specific. What's not? Right, that's it. It's what's here that's not here already. And you can tell by looking at it, well, the H and the NO3, and those exist together. So it's definitely HNO3. It's a single replacement reaction. They're asking you to think backwards, basically. A fancy word for that's called retrosynthesis. First time I heard that, my mind was blown. Telling you now that's called retrosynthesis when you have to think backwards. Reaction 2. You've now got barium plus something. When I react it together, I get this. What is the thing that's missing?
Water, H2O.
Yes. You got it. That's the missing part. They're asking for one of the missing reactants. So H2O. Would they give you the mark if you just said water? All right. Part 2. Name X. Write an equation for its formation. Barium, when I heat it in the air, becomes X. What is barium reacting with in the air? When they say heat in the air, what does it mean they're reacting with? What could you be reacting with in the air? It's oxygen. It's oxygen. When we burn something, we're reacting it with oxygen. When we heat it in the air. Plus O2. You should memorize that too. Whenever you see heat in air, that's another way of saying we're reacting this with oxygen. So then, well, what is this then? Ba plus O2. Do we know that type of reaction? Synthesis. Element plus element makes compound. What's the compound? When I put Ba and O together. This.
Yeah. 2 in front of BAO and 2 in front of BAO.
Which that's the answer for down there, right? Because it has the equation. That's that. You can put an arrow to that if you want, instead of writing it again. And what's the name of X? Barium oxide. So if when they said the name, you say BAO, you don't get the mark. You have to say the name if they ask for the name. So they're asking for the actual name of the compound. It is barium oxide. So this is how this shows up on paper 2. Or how it can show up on paper 2 from what we've seen before. In pre-ACE, I would have given this as an extra credit, I'm pretty sure. It would have totally been an extra credit style question. Because in the pre-ACE class, I regularly give ACE questions as extra credit questions. Everyone just looks at it and they're like, "Ooh," and then a couple students that comes in. All right, we've got one more thing to go over today before we do the lab. A specific type of reaction. I decided this is a later standard, but this is the other type of reaction you can have in the very same lab we do today. It's called a thermal decomposition. Underline the word thermal. What does that mean? Add heat. So here you're going to see these arrows. Put a triangle above the arrow. This is for you to remember. When you have a thermal decomposition, this means you are adding heat to decompose a compound. There are 2 different types of thermal decompositions you need to memorize. One for carbonates, and one for nitrates. They decompose in a slightly different manner. And there's a formula for each one. I gave a specific reaction here. If I was to give a formula for carbonates, it would look like this. XCO3 with heat. What do you think the products are? Yes, Alex, go ahead, grab the cup. What do you think the products are here? Looking at the template for the example reaction I gave you, what is the thermal decomposition of any carbonate? XO, meaning whatever that metal is, and oxygen, plus carbon dioxide. This is the formula for carbonates. You need to memorize it. For nitrates, you also need to memorize the formula because it is slightly different. So formula for nitrates. XNO3, 2 goes to XO plus NO2 plus O2. This is not balanced. I'm going to give you the balancing right now, 2 and 0.5. That actually, and I'll explain how to get that shortly. The note on the bottom here, you also have to know. This is part of the standard. And the reason why is not explained until A-level chemistry. But you may be asked about how much energy it takes to decompose. As you go down a group of the periodic table, it takes more energy to decompose the compound. And so that's just something you have to memorize. As I go down the periodic table, it's going to require more energy, more heat to decompose this compound. So what you're going to notice in the labs that we do, if we do a thermal decomposition, we can only do for like magnesium or calcium. We will not be able to do a strontium carbonate decomposition because our materials are not hot enough. Our burners are not hot enough to do it. And so it takes higher temperatures, you go down the periodic table. That's just something you got to memorize. The reasons have to do with charge density and ion polarization, words that you don't have to know. It's at an A-level study that we discussed the reasons why. So it's just you have to know it. It's a thing. So knowing that, and I hope you wrote down the types of reactions. There's a few questions we're going to do on the standard before we move to the lab. First one, for checkup 3. Which one of the 3 compounds will decompose at the lowest temperature? So they give you calcium carbonate, strontium carbonate, and barium carbonate. Looking at the periodic trend, which would decompose at the lowest temperature? What would we be looking for? We would be looking at which one's highest up on the periodic table. So given that they're all carbonates, we would be looking for calcium versus strontium versus barium. The one that's highest up on the periodic table is calcium. And what about the next group? Barium, calcium, magnesium nitrate. Which one decomposes lowest temperature that we would be able to decompose the easiest.
Magnesium.
It's going to be magnesium. So again, it's the highest up on the periodic table would be the lowest temperature. As I go down the periodic table, it's the highest temperature. Decompose. So this is magnesium nitrate. We're going to take a look at a couple more questions with this before we go forward. Looking at time, I don't know that we're going to have time for the math question. Balanced decomposition. Can you do the thermal decomposition for strontium carbonate? This is memorizing the template. Strontium carbonate. What's the formula for that compound?
SR.
You gotta memorize carbonate is CO3 2 minus, right? Strontium carbonate, SrCO.
3.
Now, how do I decompose it? What are the products gonna be? SRO. And the other one is
CO2.
CO2. I would fill in these states of matter. This is a solid, I heat it up. This is a solid, and carbon dioxide is a gas. Yes, welcome back. Is this balanced? It is. 3 oxygen is 3 oxygen. One strontium, one carbon, one carbon. It's balanced. Barium nitrates. What about that?
BaNO3.
How many nitrates for barium nitrate?
1.
Barium has a +2 charge. You gotta memorize those polyatomics, right? Nitrate is a -1. It's BaNO3 too. Now, what are my products? Plus. The template is it's the metal oxide, nitrogen dioxide, and oxygen. Is this balanced? So let's talk about balancing it real quick. You can just memorize it from the template, but I'm going to explain why I would go the route we go. You have 2 nitrogens here, right? So put a 2 in front of metal 2. That's where you would begin. Here's the strange part. How many oxygens do you have right now on the product side? 1 plus 4 plus 2, which is
7.
7. You've got 7 oxygens on the product side, and you've got 6 oxygens on the reactant side. So one nifty little trick to change these to be the same without doing too much work is recognizing, first of all, oxygens by itself here, right? It's alone. Is there a number we could change this to, put a number in the front, to make 7 total oxygens on this side equal to 6 on the other?
0.5.
It's a half, or 0.5. That's why that number is there, because that will basically change this to a 1, which changes that to a 6. It's a trick. So if you get some kind of weird situation, look for tricks. Look for elements that are by themselves. If you can try to balance those, that'll work out for you. What are the states of matter? Barium nitrate is a, I'll answer your question in a second, solid. Barium oxide is a
Solid.
nitrogen dioxide is a gas, and oxygen is a gas. Go ahead, Justin, before I continue. So you can put decimals as long as the total amount of atoms ends up being a whole number. So for example, if you put 0.1 O2s, that's impossible. Because you would be saying that you have 0.2 atoms of oxygen. You can't do that. So that's a no. But this is okay because when you do 0.5 times 2, right? 0.5 times 2 still gives you a whole number. So as long as the decimal you put ends up with a whole number of atoms, the answer is yes. Yes. Bathroom? Go ahead, grab the pass. All right. A couple of things I want to make note of here before we continue. This is going to go into, we are starting to get close to our lab component of the class. So a couple of things I want to make note of here. Some of you may be aware of this, some of you may not be. But S-block metals. What is an S-block metal?
Metal and metal.
Group 1
Group
and Group 2 metals. Compounds with S-block metals, or Group 1 and 2, are white solids, meaning they have no color, they're just white. White, they say. Cambridge uses white. Although sodium chloride looks kind of clear to me. They say white solids. So if you have a colored compound, what does that mean? Because you're going to have one today in the lab we're about to do. This is one of the reasons I'm bringing it up and one of the questions you have coming up right now. What is a colored compound? Colored ionic compounds come from transition metals. I am telling you this because actually there's a lab you're going to have, so you want to write this down now. This is really, really important information. There's a lab you're going to have called qualitative analysis. It's not the first one we're going to do, but we are going to do qualitative analysis. And in that lab, if you see a colored crystal in front of you, can you rule out some metals that it cannot be for sure? It can't be anything from group 1 or group 2, simply based on observing the color. You can figure that out. So if I have a colored ionic compound, that means that I have some kind of transition metal, or we would call that a D-block metal, something that's here in the middle. Which, like I said, we're going to have one in our lab today. That's one of the reasons I'm bringing it up. And another reason is because these are, right now, group 2 metals that we've been decomposing, and they're all white compounds. They're all white compounds. So those are boring. That's why I decided not to go this route today, because I didn't want to give you, I wanted to give you something a little bit more interesting, so I'm giving you a colored compound to work with today in your lab. But you never know if you're going to get boring or interesting on your Cambridge exam. All right, this is another question from paper 2 that I want to look at before we start going over the lab. Element X is a metal. X reacts with oxygen to form a black solid oxide. They give you the oxidation number of this oxide is +2. The carbonate is a green solid. It decomposes on heating to form the oxide and a colorless gas. From the information given, can you state 2 similarities and 1 difference that metal X has with compounds in group 2 metals and their compounds? What's 1 similarity that element X, metal X has to group 2 metals? Reading what you saw. Go ahead. Exist as solids. Okay. Another similarity. Go ahead. Same charge, right? What's the difference? It's colored compared to group 2 metals are colorless. So group 2 metal oxides are colorless. Or white. Whereas XO is black. You could have also said that XCO3 is green, whereas group 2 carbonates are white. You could have also said that, and that would also qualify as a difference. So the difference is in color. What's the formula of the oxide of X, knowing that the charges are the same? If I were to put X together with oxygen, what would the formula be for the oxide? XO. That's a mark to say that, but that's the formula. And then what's the equation for XCO3 when heated? Is this not the basic carbonate equation? So it would just be memorizing when heated it becomes, and you don't have to write the triangle on the top, but you can if you want, they won't count it off if you do. It would be CO2, no X there though, and the other product is? It doesn't matter the order you write them in, I just heard CO2 first, it would be XO. Or XO plus CO2, order doesn't matter. All right, we have one last question, paper one, it's a quick one. Yeah. This one? Take a picture. All right, I want to make sure we're getting started for the lab real quickly. Yes, ma'am. Okay. Yes. I believe Mariani's out. You'll have to wait till I finish explaining the lab because I'm about to go to that. Rosalind, are you good? Yeah. Okay. This is the last question we're going to do. I'll save the math for next class. I figured I might have to. What are the trends? There's a stoichiometry question, but I don't want to get lost in stoichiometry. What are the trends in the stated properties as group 2 is descended from magnesium to barium? What are the trends? So this is a new type of question unlocked because this was something that was in today's standard, but also notice how it includes an earlier standard from earlier this year. So group 2 of my periodic table. As I go down the group and I'm comparing. The decomposition temperature of the carbonate, that's what we looked at today. Does it decrease or increase?
Increase.
Increase, right? So that puts us at either C or B. But in order to answer correctly, you also have to know about the first ionization energy, which you should be studying as it's going to be on your quarterly next week anyway. Don't you love how Cambridge questions are integrated? As I go down the periodic table, does it require more or less energy to take electrons from an element? Because they get bigger, right? As they get bigger, it takes less energy, so it would be decreases. And the answer here is the type of paper 1 question you could get here. All right, this I'm going to save for Wednesday. I'll make sure to put a question like this in your bell work section because it is in your homework. The homework that's going to post today, I'm giving a little bit of additional time to do, but I do encourage you, if you're working through it and you get confused, to come to tutoring tomorrow. Before we start the lab, I want to make sure to pass out the homework so I don't forget. Once I start talking about the lab, I often forget. So I'm going to make sure to pass you out the written homework. So put this away, and then we're going to start talking about the lab. Don't put your notes away yet because there's a couple notes to make about the lab. Here we go. Yes. Oh, you have? Oh. Okay. All right. So what are we doing today? We are doing something called gravimetric analysis. And every time I hear that word, I'm like, huh? This stands for gravity, I think.
Oh.
So that's where the grava comes from. Whenever you see gravimetric analysis, and I've seen it on paper 3 before, it's a fancy term for saying you are going to analyze by measuring mass. You're going to be measuring mass. In today's lab, you are going to be using something called a crucible. Do you remember what a crucible is? Anybody remember what that is? No, but you had to memorize lab equipment, so in case you're unsure, it looks kind of like an acorn. It's a terrible drawing, but whatever. And so this is a little crucible, and the purpose of a crucible is to heat to very high temperature. Heat what's inside to high temps. So today you're going to be working with a crucible. There are 9 lab stations set up, and there are 15 of you present in class today. So you'll be either in groups of 1 or 2. You can get together in pairs. But if you want to work by yourself, there's a couple of lab stations that'll be open because there are a few students missing today. But it's 1 or 2 for lab groups for today. So what you're going to be doing is this. You're going to be heating. This is called a tripod down here. And you're going to have something called a pipe clay triangle that you put the crucible on. This right here is called a pipe clay triangle. And then we're going to put a Bunsen burner under that triangle, and we're going to use that to heat what's inside of here up. So the goal of today's lab is you are going to have some copper sulfate. Aha, the bell work is back, but it's not the same number. I guarantee you, I already did the lab, and I know what it is. Times something H2O. And you're going to have these crystals. They're going to be blue crystals. You'll see them at your, no, it's not math. Those of you who watch Breaking Bad. It is copper sulfate. CuSO4 times blank H2O. Our goal is to figure out how much H2O is there. How much H2O is bound to the copper sulfate. That's what we're going to be doing. So the way we're going to do that is we're going to be heating it up using a Bunsen burner. And all the water is going to turn into steam and it's going to leave. So you're going to be measuring the mass of this before you heat it, and then you're going to be measuring the mass after you heat it. So I gave some example tables and data here, but I have the exact table that you need. I put it in the back of the classroom. So don't move yet, but I'm going to move to the back to show you a few things. In the back, I have a small setup. I have a Bunsen burner. I have a crucible with the lab, because I did your lab earlier. I typically do your lab before you do to check for accuracy. And then I have my substance here that I'm checking. And then in order to begin, what is my safety? What is our safety for today? We're going to want gloves, and we're going to want some kind of protective eyewear. Either have glasses or you need to grab goggles. Where are goggles in this classroom? Just in case. Goggles are over here. So when it's time to begin, you're going to grab goggles over here. There's 2 drawers full of them. You pick whichever ones you want. There's sleek ones, and then there's the big, thick ones, whichever ones you prefer. The other thing is your hair needs to be tied back. If you have hair that falls in front of you, you need to make sure it's tied back. You're good. Yeah, things are okay. As long as it's not like my hair in the front falling forward. So then the next thing is you're actually going to be practicing today, if you have the time, with lighting your Bunsen burner. And so what I have here is I'm going to show you this method real quick because this will help you as you get started. I haven't passed out the lab yet, so don't move yet. So are we going to want our gloves for this lab? Yes? We want protective eyewear. You're going to turn on your burner when it's time to heat your crucible, but before that, you're going to be practicing with, you know what these are called? Tongs. You're going to be practicing putting your crucible on the pipe clay triangle. When your crucible is hot, you do not want to touch it with your hands. Why not? 1,500 degrees Celsius will leave a nasty burn. Do not touch a hot crucible. Do not do it. So then, I put this. You're going to practice with this when you get to your table. You should practice it a couple times to make sure that you have good control of taking your crucible on and off, especially because remember, you're going to have to lift the crucible and put it onto your table at some point. And do you touch that with your hands when it's hot? No, you do not. And so what I do is I put my crucible here, I practice it on. You'll need to gonna practice with this today too. Once your burner's lit, then you put it underneath your crucible. You can actually adjust the nozzle here to adjust your flame. Notice what I do here. Turning with my fingers until I see the flame turns to. What's happening here? Why is the color of the flame changing?
More heat?
Which one's higher? This is more blue. This goes to lower temperature. And so you adjust it. The instructions on the lab will say low heat, so like that. You're going to hold it for 4 minutes. Does anybody know how to use a stopwatch? We'll be working with those today too. And then when you're done, you're going to take the crucible off, but first you have to let the crucible wait for 5 minutes to cool. Do not immediately take the crucible off once you have turned the Bunsen burner off, because if you immediately put the crucible on the table, there's going to be a nice dent. And there's already dents on those tables. Don't add more, please. All right, so at this point, I'm passing out the lab handout. For the lab itself, you're going to have about 40 to 45 minutes to do the lab. I did it, like I said, in 15. If you need the table, I wrote the data chart for this first lab out for you because it's your first practice. So I'm giving you the data chart. You just have to copy it down so that you know what information you need to get. In future labs, you're going to have to start getting comfortable with creating your own data charts, but not today. I'm passing the lab now. Write your name. You have to finish the lab before you leave. The calculations are going to be due by next class. So it'll be turned in on paper. So you're going to turn in your lab next class on paper. First thing before you begin, write your name. Then you're going to pick a lab table, get on your safety gear, and then when you're ready to get lit, let me know. There you go. Write your name on the top before getting started, how to get your safety equipment, and then you can begin. Go ahead. Did you get all of this? It's always in the front if ever that happens. All right, so you're going to go ahead, grab your safety gear. You need gloves. You need goggles. When you're ready to get your Bunsen burners lit, let me know. But you have to read the instructions. Follow the instructions first. Copy the data table. I've got rulers and pencils for you at the lab table. This is a pretty quick lab. You should be able to finish by the end of the class. Gravimetric analysis. Pick a lab station. 1, 2, 3, 4, 5, 6, 7, 8, or 10. 9 has 2 roots of the top. That's why it's not being used. 1 or 2 people max. If you have questions about any of the instructions, let me know. The data chart to copy is over there if you want to get started with that. You know what data you have to record. Yes, go grab the pass. So you can, if you want to take a picture of it, while you can start right here. The parts here, you have to have the first 3 lines. Bottom part to help. Gloves, protective eyewear, hair back. Shirts for me, you have? You need one for that? Remember, you're either going to be working by yourself or with one other person. There's 9 stations altogether. On the actual paper 3, by the end of the year, you got to be working by yourself. By the end of the year.
Sorry, because of Jimmy doesn't have light. That's because of I had it.
Make sure to read through the instructions, write your data table down while you're waiting. If you're waiting for your partner, write your data table down. I created it for you, the information you need to have. The first 3 parts are the parts that you need for the grade. The last 3 parts, I wrote to help you with the calculation. Yeah. Like you have to create that yourself on the test, but we're not there yet. So for now, I'm using it for you. Yeah, you write that right now. The idea is that you have to take the mass of the crucible first, then you have to put the solid in it, then you have to take the mass of the crucible again, the solid, and then you have to heat it and dry the water out, and then take the mass again. What do you need, Tasha? That was for an escape room that class. They had to hit a tablet with a reaction. Without touching it. They couldn't press the line. It has nothing to do with anything. I just haven't taken it off yet. Yes. Yes. You need to write that part down into this area. This area right here. That's where they give you. The first 3 parts are the parts you have to write down, the parts that start and the parts that I have. The first 3 parts are the parts that are. Mass of crucible plus Fe3 plus lead. Yeah. The bigger section they give you is the room for the data chart. And I've given you exactly how you should write it. Make sure you probably put it on top. Well, the crucible has to wash it first, then the lid should go on. We got the idea. Make sure you practice with putting your crucible on and off of your pipe clay triangle. Oh, you shouldn't be using your hands for that. No. You start here, and then you do this. Get a little bit out. You add this. But you shouldn't have your lid. You take your lid with your lid. So you want to get 2.2 to 2.4. You're working by yourself or with someone else? You want to get 2.2 to 2.4. Have you tested putting this on and off of your first book? You tested how to, you tried putting this on here? Yeah. You have or you haven't? Oh, okay. So then 2.2 to 2.4. You can trade on the here. These are good. The ones that we use. So what would be 2.2 to 2.4? You gotta add a little bit of time so you should have your lid on too, no? Wait. Oh, you zeroed your. You should not zero it because they're asking you to write the actual math of the table. You don't have a crucible? Let me try. What's the name of your last? Oh, because you have a dirty pipe. Not you, but who works for you. That and that's your A level had a dirty pipe.
Yes.
But you can clean it off. Well, it depends, what's your starting amount? Your starting amount is 6.4? Oh, so that should be good. So make sure you work out the 30 amount.
Listen, you burn that.
Got lucky that time.
How did I make it?
Be careful, practice with your crucibles, putting them on and off the pipe clay triangle, they break easily. And they cost money. So I will pick them up.
Okay, well, it's the.
When you're ready to practice with your Bunsen burner, let me know when you're ready to get lit. It should only be once the crucible is on your pipe clay triangle with the proper amount of solid inside, and you recorded this in your data table. Yes. You gotta practice with the. Oh no! Got lucky that time. No, it's best to grab it, believe it or not, let me tell you. It's best to grab it and probably. This right here is very good at gripping, so the best grip is right. Okay, let me get the door real quick and then I'll answer that. That's Alina coming back. No, that's how we can hear you in a lab. I never know. You may want to use like grab it. Okay, let me help you with your. You need to read 0.00. Someone can reach 0.00. This is start. Not be done with that. It should be straight up and down. So if you have to fix it, we'll fix it with your top. When it's hot, remember you can't touch it. When it's hot, you can't touch it.
What should we like?
This button for start, that button for stop, that button for. Practice with your stopwatches too. You have to follow the
No,
way you do it. You're not following the way you're supposed to do it.
Third year structure measure 2.3 to this.
That has to get into the crucible, right? That all has to get into the crucible.
Yes, I know.
It's more accurate if you do it directly into the crucible. Because although these are big crystals, so it's okay. Sometimes you'll be working with little things, little tiny ones, but it'd be much better if you just put them down. Here it's okay though. As long as you're, using your gloves.
How much seconds?
All right. So make sure you're reading instructions carefully. You're adding the proper amount of solid Fe3 into your crucible. There are instructions to read. Okay. Does it say you have to lid on it?
Put it down.
No lid? You wait to cover. No lid. Go ahead and again. Hold the bottom. I can hold the bottom if you want. Which hand are you going to?
So now the process is this. Hold it up here. We have to put it on
So now it tells you who plays it not necessary. So actually,
come back.
All right. Let me know whenever you're ready. Okay, so we don't put it underneath until we've already lit it. So you gotta lefty loosey to turn it on. You hear it? Now, we're gonna hold the bottom. I'll hold the bottom for you. Because you're gonna try to light it. So, when you light it, start off with light it, and I'll hold the bottom. I'm holding it so I can take care of the shirt. Yeah. Now, we want to adjust the snake to its light. How do we adjust? Don't touch that. That's not really we want the snake to be gentle. Blue is not gentle. So, what we do is we move this spring is the adjustment for the nozzle. And so you move it up until this turns to like a yellowish. Believe it or not, that's more gentle. And so now we move it underneath the crucible. Once it's underneath the crucible, you start the timer. And then once the 4 minutes has passed, you turn the fire off. All right, I'll be coming around to help each group. I just need to ensure that you have begun. So the other thing is you want to make sure that you get it underneath straight, and then you turn the nozzle on. Every time you turn it off. All right, over here, yes. Are you ready? You ready to try it yourself? You're gonna turn it on. So this is the part. You want it to be this way. A little bit above. You can try it yourself. Oh, a little bit closer. A little closer. All right, got it. All right, so now do we have to change this to a lighter flame? You move this one along.
Yeah.
All right, time. Now we'll take this. Yeah. You need to take that. Not calibrated, you said? Just hit that. But you can take on the thing. After you see it, yes. After you see it. Yes. You're not because you haven't put the crucible on there. And then the color that in there. Sorry? You don't have a burn? Okay. Sorry. Alright, have you need to get this on there to the top. Or starting. Let me know when you're ready. Alright, this group is ready. Who's doing the ceremony? So it's this gentle.
You need therapy. But if not, you need more busy.
All right, so which group do I need to work with? All right, that's
I missed 4 or 5
Let it sit for 4 minutes, then turn the fire off, let it sit for 5 minutes. So it's 4 minutes, turn the fire off, let it sit for 5 minutes. Are we ready here? Okay, and Peter, can you sit down? Alright, the next thing is this is the letter. Yeah. Spark, you have to go into Spark. This is the direction that we're going to have. You want to write Spark, stop. You want to use it on the bottom or on the camera too, on the last one. So now, 24.18, and once you add it to 3, the camera should switch carefully underneath your crucible, start the timer, once it's under the, oh my gosh. Is it six? I guess. You can fix it, just be careful. Oh my god. I think you have it upside down. Okay. Okay. Yeah, let it cook. You got your timer going? Alright. Let it cook for 5 minutes. Yeah.
Is that 5 minutes, right?
2.2. 4 minutes. And then 5 after you turn it off, 5 more minutes. You gotta sit for 5 minutes before you do anything. Alright, here, you ready? Who's gonna do your lighting? Alright. Are you ready to put the timer? Yep. 4 minutes and 5 minutes. Alright, I know.
Don't get distracted.
You have this already ready?
I won't.
Alright.
Don't take forever either. Hurry up.
Four minutes. What happened? Let it chill for 5 minutes, right? Alright, you ready? Put your crucible on. Turn it off. Your crucible has to be out there. Use it up there. Alright, wait.
By the way,
Yeah, you're done with it. Yeah, the only thing that's like remember, once you're done and you re-wait after the 5 minutes cool down time, start working out the math. There are math questions to answer. You gotta use your data to come up with the answers, like the bell word. Those are the ones you have to have. Aaron, this part, calculating the math. Are you lighting it? Who's lighting it? Okay. Then you look first, you gotta get the first, and then have to get how will the box Alright, no, so how we adjust is get the double thing. Higher. No. Push it under and start to push it under carefully. Then under the crucible and start to time. Like cooking, right? Alright, are you ready? Alright, you gotta, do you have your best principle on the top?
Until that. Take it off.
Justin.
Well,
Would make it rise a little bit.
Get left the churches now. This way. I know it
remember, let's sit for 5 minutes. Cool. So the grading, the marks are there. So the examiner on the actual exam would say check mark or X or whatever marks you got. Now I did the tables for you, so you should get the marks for the table. The marks for accuracy, that's from experimental technique. Yeah, yeah. You will have to write one yourself on the table. Yeah? It does.
It's like a little bit like.
No, it's not. It's okay. I'm sorry. 5 minutes before you wait. Yeah. You gotta let it cool down. You don't wanna. All right, are we starting? You don't have your first one.
Pardon the interruption, teachers and students. At this time, all student ambassadors, please report to room 30 with your belongings. At this time, student ambassadors report to room 30 with all your belongings. Thank you.
Start working out your math before you leave so you can ask questions. I already finished this lab in advance of you, so you can ask any questions you may have. Yeah, sorry. What do you need? My iPhone charger? The pink one?
I'm all right.
That is an emergency.
Thank you.
Of sorts. There's chargers all over the classroom. Like chargers. 4 minutes, remember? And then you turn it off in 5 minutes. Once you get your measured math, start working out your calculation. Oh, for the later part? You finished? There's a part that says you gotta. So you just need to put there is a part you need to do before you go. Look on the back page after you've pulled off part C. Read through that. You need to do that before you go. After you've weighed your residue. Part C, because that's the thing you have to do. You have to do that after. The rest you do homework.
Yes.
The math you do homework. That is one for me without doing part thing. Well, explain. You can't see the observation unless you're here, so. The part one you have to do here. Write down your observation. No, you just put it on the table. As long as it's in the 5 minutes. It's fine. If we don't have any for math, you don't need it. The table is fine. The table is fine. You can put it at the table. You can put it on the table. After the 5 minutes is back, you can go on the table. Yes. You have to take it off. Press the 0 key and put it back. Yeah, take it off. Take the 0 key. Put it back on. Why me? Make sure you weigh your residue before you go. You must weigh your residue. Start working on the math if you can. I can help with the math while I'm here. Or I can tell you if you're right or not. No.
So we do see.
Yeah, do C before you leave. Do part C before you leave. After you measure the math.
All right. Here's water.
That's the water there. Do part C before you leave. That's okay. I'll do it, or I'll have my lab extended tomorrow. In period 5, you have lab. Yeah, I thought. You get a grade. You get an A. You get an A. Setting up lab. What is learning to you? What was your observation?
We're talking.
Do part C before leaving today. Don't forget part C. It's an observation you need to take.
No. These are.
You're welcome. Rehydrate. Yes, before you got how about
No.
All right, remember that whatever you can't finish in class, if you can't finish it in class, this is due at the beginning of class on paper on Wednesday. I'm also here tomorrow during tutoring, 2:30 p.m. if you need help with this or the homework. You gotta finish part C before you leave.
Probably all.
Part C, don't forget to do part C before leaving. The third part you're not going to be able to have in your calculus. So don't worry about it. It's about the enthalpy, which means just reaction. Not reaction, reaction.
Oh.
You can earn all the other money. X is a whole number. The amount of moles of water compared to the amount of moles of water. I did it earlier. I got an answer. It is not that. I actually did this lab. I usually do your labs before you do. Because the way that they run the lab, they take your lab, they take my lab, and they compare the results. So, for the accuracy, not for the calculation. Accuracy are based on my results. That means not all water. And that's because they said I'm not, and perhaps they didn't get a copy if you didn't see it. So there's some. I mean, I would have two jobs. You're only gonna be able to earn But the one you can't do it's your I'm scared what the reaction is. This is reaction when water's leaking. When water's in it, it starts blue. When you add water to the hydrocrystal, then it turns darker blue. That is not hydrocrystal, but then when you add water back, and it reabsorbs. Every single periodic table is one of they're doing that right now, like periodic table.
Any copies of this and something in the black market?
However, it's a lot of building curves. Yes. It's not cheap.
Just set up
You are the four. That means you want the rest. You and the four. What's left? Like what didn't.
like you are not capitalizing.
What left is what? We want how much is left. Also, I mean, yeah, perfect.
Good afternoon, Golden Lions. This is Devin, and these are your afternoon announcements. Students, please remember to check your Cambridge email daily and report to school in proper CIE uniform. Make sure your outer wear is solid white, black, or red. Also, please wear your student ID badge around your neck at all times. Attention will be issued to students who not adhere to the uniform policy. Please remember that you must wear your student ID every day. If you lost your ID, the cost for replacement is $5. If you receive a replacement ID, you must pay for a full fee. Students who have unpaid balances will not be allowed to participate in field trips. Yearbooks on sale now. They are $50 now until October 31st. The price will rise afterward. Buy your yearbook now to get a spot at the end of the year signing party. Go to www.yearbookordercenter.com. Order number is 21027. Attention students, if you purchase a homecoming ticket, you must submit a field trip form. Field trip forms are available outside Ms. Sands Gomez's office. Students, please help us prepare for a trunk or treat by donating bags of individually wrapped candy. You may drop off your donations at Ms. Sands Gomez's office. Community service hours will be awarded for your donations. This concludes our afternoon announcements. Enjoy the rest of your day, CIE.
Already the right things, I see it. No, I clean it up first. No, I'll clean it up for you. You just have to start with your type of whatever that is. Just, if you got your house, just rub it down. Throw out your gloves, put your goggles away. If you wore goggles. Other than that, Jen, start getting ready to go. Throw out your gloves. Put away goggles. Leave everything else to the lab tables out. Work on cleanup during tutoring time today. Great.
It's more blue with water.
No, they're mine now.
Alright, so that was your intro lab. Intro lab. You got another lab on Friday. 2 labs this week. Titration on Friday. Mentally prepare yourself for that. Alright, let me get the door. Damani, your iPad. You got the same one that I did. I feel like I've made this comment in previous chemistry at one point. Yeah, because look, mine is this one, and I have the Apple Pencil. It's got the same exact, the same case and everything. I bought it in 2020, right when the pandemic started, like for teaching online. Because remember I would teach over there? I literally just switched this year to go back up to the front. The first year, that's really like kind of how it was pre-COVID. I had to from there because that worked on. That's the short story. It was really bad. It did. At the end of the year, I was like, am I going to have to buy a new iPad? But no, they bought a new board, thankfully. Because this is much better. It's much clearer. Much better. Yeah, no, you could barely even see it. That's why everybody had to be logged in their computers. You couldn't even barely see it. It was so fuzzy what was up on that board. Yeah, light. It was terrible. I couldn't stand it. And my old school had those nicer TVs, like in 2018, we had gotten them.
Gloves and goggles.
Yeah, make sure to throw out your gloves, put your goggles away. Lab is due next class.
I'm still at 1%.
And check Google Classroom for your homework due date, but I believe I gave some extra time on that. Yes. Hey, you finished all the math?
Hey. That's base. I mean, that's not.
And you're sexist.
You. How? I would call it base. You know what I mean? I said it with you. Come on.
Can you not see? I am busy.
These people, that has to be racist.
You're still talking. Shut up. I haven't even started
That
my
has to
book.
be racist.
How is that racist?
Oh my gosh, she's so turbulent sometimes.
Oh, I didn't see the link.
You do right there. That's a war crime. It's a war crime. Show that to me. Come on, go on. Sorry.
I somehow found this while I was in my math class with the teacher was letting me put this.
No worries. What's up, line? I have the big.
No, my bad.
You have 2 types to choose from. This and.
Alexander. Right. It is. Your first, these are your run of the year. How did that? Why did you run?
Let me check your math. Okay, I don't see where you're coming up with this. I don't know, like, I don't see your supporting evidence. You got the grams
We got
of,
0.82 grams, we got the molar.
so you have 0.71 grams.
Yes, sir. We thought that was
Did you
16.
what's 0.71 divided by 18? What's 0.71 divided by 18?
We thought that was just the.
I'm trying to figure out where the issue is because I don't see that.
Thank you.
You're welcome. So you've got, hi, you can come in.
I'm here to make up that test.
Yes. So 0.71 divided by 18, right? So 0.0394 is what I did. 0.71 divided by 18. 0.0394. Okay, how come I have different? I have 0.71. You have 0.71?
Oh, I did that.
Okay. So I got
So we're good.
0.0394.
Portion of
here,
support.
and then this is
Oh,
0.78
you were three or
divided by
something?
159.6.
You were three or
0.0111. It's pre-is today, just for homework help. These two numbers have to be divided. 0.0394 divided by 0.0111. So I have no idea how you came up with what you came up with because this is what you would get back to.
Wait, I thought that this was the residue and this was.
And that's the mass, that's the mass of copper sulfate. You need the moles of copper sulfate in comparison to the moles of copper for what you have to get here, right?
I thought you were just the grams.
Because to get the ratio, this has to be moles. It has to be moles. It has to be moles. So you need the moles of each. So this one, you have to do 1.78 divided by 159.6 for copper sulfate, and for water, it's 0.71 divided by 18. That gives you the moles. I did the work already. Like, I have it written here. But the answer should be close to this. Definitely not 20 something. This is closer to. All right, Sophia, let me go to yours first. Let me